On top of things. That's okay. This is a good sized class. We should be able to get lots of time to be able to work together. So, our first unit's on algebra. Really, technically the unit should be called rationals. Like the curriculum itself calls for us to really work with a lot of fractions. I'm just gonna fast forward in my notes, like well past today and tomorrow. I want to show you something typical that you're gonna be asked to do. And some of you guys who are in my 20-1 class will recognize something like this. This is what the unit is basically about. We did this last year.
Is that like one of the hardest questions?
This is one of the harder questions. No. This is one of the cool things about how 30-2 works, is that it really is a rehash of part of 20-1. Yeah. So for some of you that I taught last year, you'll be like, okay, we did this before. So don't freak out. I'll teach you stuff. Okay. So what I do want to do, though, is just kind of start from the very beginning with some algebra skills, just because it's been a while. So, like, basically, like the end point of what we need to be able to do would look like this. If you can solve a question like this, then this unit's going to be good for you. Do you guys remember doing this?
I remember vaguely, I just don't know how to get there.
Fair enough. Okay.
I
Well,
forget.
that's why we'll start over from scratch. So. 20-1 to 30-2 is actually a really good pathway to take, I think, because you probably built a lot of good skills last year when I taught you, and then moving forward, then this maybe fits your career goals better than 30-1. Okay, bit of terminology then. Do you guys know these words, expression versus equation? Basically, an expression has letters in it, sure, or numbers, but the key thing is there's no equal sign. An equation actually has an equal sign. So like this root 25 right here, that's an expression. This root x squared right here, that's an expression. This crazy thing, whatever this thing is right here, expression. But here, a equals pi r squared, equation. Does that make sense? So the way I want to kind of start from scratch is we're going to just begin with just expressions at first. And then by the end of the unit, we'll throw in equal signs and we'll work on solving them. Actually, no, I take that back. We're actually going to start solving right away off the bat here. We're just not going to solve the fraction stuff just yet. So maybe you guys have heard the word solve before. Basically, solve means just get x by itself, or y, or z, or m, whatever the letter happens to be. So here's some basic thoughts. You can add, subtract, multiply, or divide both sides of an equation if you need to. You can combine like terms. Do you guys know what like terms are?
Yeah. It's with the same letter.
Sure. If I gave you 2x plus 2y, can you put them together?
No.
But if it was 2x plus 3x, can you put them together? You'd have 5x. Makes sense. What if one of them was squared?
No.
Then no. You can also work with common denominators. I'll get to that when we need to. So honestly, I think the best way to start this is let's just hop into some examples. Let's do them as a group. So here's our first example. This is an equation, 3x equals 6. This may be almost borderline simple, almost insulting, but how do you get x by itself? That's it, yeah. That's the basic concept. Does that make sense? Just divide this side by 3. Divide this side by 3. 3 divided by 3 goes away. 6 divided by 3 means x is 2. Ta-da! Straightforward? Cool. Okay, let me try jumping ahead to a more challenging one. Let's do this one over here. Okay, so you've got 5x plus 3 equals 12. Good. Can we talk about y, though, before we start? Do you guys know the term bedmass? You ever heard that before?
Yeah.
Brackets exponents, division, multiply, add, subtract. Okay. The basic concept behind bedmass is there's an order of operations they have to do things in. Only when you solve an equation, you actually have to go backwards the other way. So you have to do like samdeb when you solve an equation. So like the first thing you have to do is deal with any subtract or add signs. Do we have a subtract or add sign? Sure, you have a plus 3 right here. So the first thing we have to do is subtract the 3 from both sides, which leaves you with 5x equaling Cool. And then after we've dealt with add and subtract, then do we have any division or multiply? Yeah, then do your division and divide by 5.
It's 1.8.
Cool. Does that make sense? Cool. Well, why don't we jump down and do number 5 then? Cool. So there's the first thought here is before we can actually do anything, we should deal with like terms. I'll do it in color coordinated here. You've got red and red and red. All of those have X's. And right here we have 2 that are numbers as opposed to letter numbers. We have to combine all of the like terms together. So usually the suggestion is put all of your X's on one side and put all of the numbers on the other side. I always like to joke with students that sometimes it's best to group all of your X's. Get rid of all of your X's. Just get them far, far away. X's. Double entendre? Thomas is laughing.
I get it.
You get it now? Oh, shush. It was lame, wasn't it? You were laughing at me. Sometimes it's good just to get rid of all of your X's and just put them far, far away from you. See? Yeah. So, what I might recommend then is let's take all of our X's and let's put them all on the far side over here. So I'll do this in red.
Wouldn't it be easier to move the 3x over to the other side?
Sure, we can do that too if you like.
Well, with 20x.
Sure, let's do that then. Why don't we bring all the X's over to this side? So let's bring this 3x onto this side, which means you got to subtract 3x from both sides. So if you kind of like get rid of 3x from both sides now, how many X's do you have? Well, you have negative 8, and then you have to subtract 9 more. That's negative 17. And then, good, negative 20 is correct. Does that make sense though? If you can do that in your head, by the way, that's fine. Like, you can just do it in your head. Okay. You have to take the numbers though and put them on the other side though. So there's already a 15 on this side here, but there's a 2. So you'll have to subtract 2 from both sides, which means the 15 minus 2, which is 13. Okay. And then divide by minus 20 on both sides. So x is minus 13 over 20. Does that make sense?
Hey, Shelf, I forget, what do you do when you get an answer that's just repeating?
You know what? For the most part, I actually recommend just leave it as this. One of the words we would have used last year is exact value. And rather than writing it as a decimal number, just leave it as the fraction.
Really?
Yeah. Yeah, just leave it as the fraction. The decimal number doesn't add anything better to the answer. It does, yeah. It makes it more complicated because you have to round a repeating number. Now, to answer your question, though, like if you had to do it that way, 13 divided by 20, I guess this one here is 0.65. So I just leave it that way? Fair enough. So let's say you had 1.3 repeating. Then you usually put a little bar over top of it. Yeah. Yeah. That's all. So, but honestly, like if you end up with like 11 over 7, just leave it as 11 over 7. It's probably preferable. Okay. How am I doing so far? Is this like borderline child play? You okay? Okay, let's fast forward to something more challenging then. Let's deal with some fractions. Okay, so general rule of fractions here. There's a term called cross multiply, which gets thrown around a lot. One of the things I discover when I teach kids math, though, is that kids try to cross multiply at the wrong times. Okay? There is only one situation in which you're allowed to cross multiply. So one more time. There's only one situation in which you're allowed to cross multiply. And that is the situation that looks like this. A fraction equals another fraction. If you have fraction equals fraction, that is the only time it's valid to cross multiply. Okay? Because here's what cross multiply really means. If you have like the number on the bottom right here, if you cross multiply this up top right there, what you're really doing is you're timesing this side by b, and you're timesing this side by b. And that's valid because what ends up happening is this bit here cancels. And then if you times this d up to the other side over here, what you're really doing is you're timesing both sides by d, and this bit cancels. Okay. However, Like in this question right here, do I have the scenario where a fraction equals a fraction?
No.
Okay, so we have to get it to that point first, then we can cross multiply. So
Up there.
why don't we start with the first one? Do I have a scenario here where a fraction equals a fraction?
No.
Sadly, no. Okay, so what we need to do is consider like terms then. This term right here has an x in it, and this guy right here is a number, that guy right here is a number. So we have to put the numbers together and the x's together. So what we really need to do is subtract 2/3 from both sides.
You shouldn't make it an actual number. You should just.
Well, that's what we can do in a second here. Let's actually find what -8 minus 2/3 is. Do you guys know how to do that in your calculators? I'll help you with it. Does everybody have one of these calculators? Do you need one? Here, I'll lend you mine for the day.
I don't know.
You have one, Do you guys have one?
I'll bring it tomorrow.
You'll bring it? Okay. Let me see whether I have one more in my bag you can steal. Yeah, I got one left.
Sorry.
I can share with you.
That'll work?
Yeah.
Sorry, guys. Okay. So this works if you have one of the TI-83 calculators. It doesn't work if you have just a generic one. So what I would do is I'd say type in -8, subtract 2/3. Okay, this will give you a decimal answer, kind of like what Cole was saying earlier. This is -8.6 repeating. But there's a button on your calculator that will turn this into a fraction for you. You got to press math, which is the third one down over here. And then the very, very first thing says frac. Right underneath alpha is math. And then it says frac. And the fraction is -26/3. So here's what this means we have now. Just gonna make this big again. 4x equals -26/3. You guys okay with that step so far? Okay. Do we have a scenario where fraction equals fraction? Well, kind of. This 4x right here,
Is it over 4?
you can make it be over 1 if you wanted to. So this is a scenario, if you like just put a 1 on the bottom here, where cross multiplying would be valid if you wanted to. So I actually would recommend that we don't cross multiply though.
Yeah.
Because there's a reason why it's not useful. Let's say that I bring this this 1 up to the side right here. That's fine.
It's still the same problem.
It doesn't. Yeah. What the number we really need to get rid of is this 4 right here. So just divide both sides by 4. So if I divide this side by 4, let's just pretend that 1 isn't there. And if we divide this side by 4, what you end up with is this 4 basically comes down to the bottom of this side of the fraction over here, and now it's gone over here. What's 3 times 4?
3 times 4.
12, yeah. So what you end up with is -20. Ooh, come on, Chris. Let me clean this up a bit here. This is a bit of a mess. There. Let's just bring the 4 down to the bottom over here. It means you have -26/12. And that's as good of an answer as we can hope for. We can reduce it, I guess. How would you reduce 26 and 12? What do they have common between them?
2.
Sure, yeah, divide them both by 2. I guess it could be -13/6.
Hey, that's what I got.
Cool.
But I didn't do that step. I just divided them before.
Sure, did you take the decimal number, divide by 4, and then fraction it?
I just divided -26/3 by 4. And
That'll
I
work.
got -13/6.
Cool, that's the same thing basically.
You can just divide it by. You can just
Yeah,
divide
just
it.
take -23/26/3, divide it by 4, and then just make it a fraction again.
Okay.
How was that one?
I don't like fractions.
Fractions are, they suck.
Yeah.
Okay, let's try another one.
Sorry.
So the whole point, by the way, behind this unit here is to be able to deal with fractions. That's really what the 30-2 unit's about. So that's why I'm going to focus on them today. Okay, let's try the second one here. Do we have a scenario where fraction equals fraction? Then we cannot just randomly start cross multiplying. Where are my like terms? Which are the two numbers? Sure. So add 7 to both sides, and you'll have x over 2, and it'll equal...
Then can you times over 2?
Sure, that'll work. If you want to think of cross multiplying, now might be a good time. This is really 23 over 1. So what you could do is you could times the 1 all the way up top here, but that does nothing. And you can take this 2 right here and times it up to the other side. So what you end up with is 1x would equal whatever 23 times 2 is. Which is 46. There you go. Yeah, so x is 46 on that one. Does that make sense? Okay, why don't we hop down and do this number 4 here then? It's pretty gross. So we got fractions galore. Are we allowed to cross multiply?
No.
Not yet. We by the way, we may not even need to cross multiply to solve the question. So like sometimes people will just start taking a 2 and timesing it and taking a 5 and timesing it. That's not valid. So we got to consider our like terms. This one and this one are numbers. And this one and this one are your x's.
We just add them together.
Yeah, basically we want to combine our like terms and you want to combine your x's.
So you're gonna have 6x plus.
Well, let's just write it out first here. Which way do you want to bring the x's? Do you want to bring the x's to the left or the right?
Left. Oh yeah. Plus 10. Oh.
So we want the x's on this side right here?
Yeah.
Okay, so that means you'll have 8x over 2, and then this guy right here, which was minus, you'll have to add 2x over 5. And then for the numbers, you already had a 3 on this side. There was a minus 7 right here, so you'll have to add 7 to the other side. You guys able to follow how I did that?
Yeah.
So this one went that way, and this one went there. Can I cross multiply?
Yes.
Do I have a fraction equaling a fraction?
No.
Not yet. We'll get there though. We'll get there. Patience, young Padawans. It's okay. Okay. You have a calculator, right? Take 8 over 2. Ignore the fact that there's an x there. Just take 8 over 2 and add 2 over 5 and turn it into some fraction. So 8 over 2 of x plus 2 over 5 of x gives you 4.4.
And it's 22 over 5.
Cool. Does that make sense how you can do that in your calculator? You need a calculator.
That showed me.
Alright, so
So why did we do that?
because we're combining like terms, this is 22 over 5x. What's 3 plus 7?
10.
Now is a time where we may want to consider our cross multiplying. Do we have fraction equals fraction?
Yeah.
If I do, that.
So it's 22x equals 50.
Sure, that'll work. What we can do now is we can get rid of these stupid fractions by cross multiplying. Now, like this 10 is really 10 over 1. So take the 1 off the bottom and times it up there. It doesn't really do anything. You just get 22x. Take the 5 off the bottom right here, cross it up. 10 times 5 is 50. One last step. There you go. Yeah, you're way ahead of me then. To get rid of that 22, just divide both sides by 22. Yeah, honestly, leave it as a fraction.
We can like reduce it.
You can do that though.
So it's like 25 over 11.
Sure. How'd you do that?
I did thinking that 22 and then said that's fraction.
That'll work. Okay, that'll work. Other rationale would be that 50 you can cut in half to get 25, and 22 you can cut in half to get 11.
Yeah. I just was being lazy.
Does that make sense? Is this something... Okay, for you guys that I taught last year, you guys recall doing this?
Yeah, I don't remember it.
Okay, Kaylee?
Yeah.
And Brady, is this stuff... How are you feeling on this? All right? Okay. You guys, let me know if I need to slow down or redo something, okay? Like, please feel free to stop me.
I just like my problem is I don't know. I don't know.
Should we try a couple more as a group and then take a break?
Yeah.
I would love it.
Yeah.
My mom says
All right, let's try a few more here.
Oh, thank you.
Kind of help fix that. Okay, so here's more issues with fractions then.
Or say same page.
I'm just doing the bottom half now. Okay, so this bottom one right here. Do we have fractions? Yes, fractions stink, obviously, right? So the key to solving fractions is find a way to make it so you have a fraction equals a fraction. Do we have that?
Over 1.
Sure, if you make this over 1, we have that scenario. So, go ahead.
Did you multiply x up? Yeah, that was my question.
Good, yeah, that's basically what we're going to do. If you take the 1 and times it up to the other side, 1 times 9 is still just 9. So, maybe if you don't even want to do cross multiply, that's fine. Take the x and times the x up to the other side.
So 4x squared equals 9.
Okay, that's where you're at. 4x squared equals 9.
And then you would divide by 4.
Good, so your next step is we want to isolate for x. Now, this one's a bit different though. You guys remember I wrote out bed mass a while back?
Yes.
This one has an exponent, which means that the exponent, unless there's brackets, the exponent has to be the last thing we deal with. Because you work backwards. You do your add, subtract first, then you do your multiply, divide, then you do your exponent. So that squared sign we're going to get rid of, but not until we're done everything else. So first divide by 4. Which means that x squared is equal to 9 over 4.
Oh, I got 1.5 after.
Okay, now, what I might recommend here though, you can rely on your calculator, I guess, but don't be afraid just to leave it as a fraction. Because our last step, by the way, 9 over 4 could be 2.25, but I would leave it though, because 2.25 doesn't help us.
Because 9 divided by 4.
You just divided the 4 up.
Yeah, I just divided the 4 from here down to the bottom.
Oh, we're still on the first question.
Oh yeah, sorry. How do you get rid of a squared sign?
You use square root.
Square root. Yeah, here's the cool thing about square rooting though. Can you square root 9?
Yeah.
When you square root 9, it's 3. And can you square root 4?
Yeah.
It's 2. There's your answer, which is 1.5 by the way.
Yeah, I got 1.5. Because, yeah.
Okay, let's try the next one. This one right here doesn't have fractions, so that's good news. So, reversing bed mass. Do we have any add or subtract to deal with? No. Do we have any multiply? Yep. We got to divide by 4, so x squared equals 4. And then square root. That's actually not fully correct.
What?
There's another answer.
2 over 1.
4 over 2.
Oh, negative 2.
Okay, so side note here. One of the things that I might have taught most of you guys, sorry, you weren't here last year, but might have taught you last year in 20-1. You would have learned this in 20-2 as well, though. Quadratics sometimes can have one answer, sometimes can have two answers. There is also the possibility that there is no answer. I might have beat that into your heads last year. Do you remember me saying this before? The idea that
those ones. I didn't have to do the full question if I knew that there was no answer.
it is actually possible that with quadratics that there is no answer. It's unsolvable. Okay. Long story short, whenever you square roots, keep in mind that there's actually a positive and a negative answer. If you take -2 and square it, it's 4. If you take +2 and square it, it's also 4. So, this one right here, when we square rooted it, it could have been +3 over 2, or it actually could have been -3 over 2.
So we have to put that for every single
You should be aware of that. Yeah. Now, it only comes up, though, when you square root things. Well, I've actually seen that before. On the diploma, they might give it multiple choice, and they'd say, like, answer for A, 5. Answer for B, -5. Answer for C, +5 and -5. And that would be the right one, where, like, you need to take the +5 and the -5. So, it could
But
come
what
up.
if they don't give you the option to do both and they say
No, they should, because whenever you square root, there is the possibility that there's two answers.
Okay.
So
it won't be that mean.
you may remember we did some stuff with graphs last year where we learned about these like curvy graphs like this, and there's like 2 different places you can get an answer.
Yeah.
This is why there's sometimes the possibility of like, here's a graph of someone going up in the air, and I ask you, when does it reach this high? That's where the answer is. There is no answer because this graph right here does not actually get that high.
They don't meet the standard.
Sure, that's a good way of phrasing it. All right, let's move on here. How do you undo a square root? Sure. Now, when you square root to get an answer, you get two answers, but the opposite is not true on this one here. There's only one answer when you square both numbers.
So you have to square both sides.
You gotta square both sides though. So when you square a square root, it just becomes x. And when you square 5, it becomes 25. But it doesn't become also negative 25. It's just, there's the positive one. Two more, then we'll take a break. This guy. So think BEDMAS. So brackets, exponents, multiply, divide, add, subtract. Let's work backwards. Do we have anything that's subtracted? I mean, there's technically a negative sign right here, but that's not it. Is there anything that's been added?
Yeah.
Okay, that means that this thing right here is not the same as, say, these guys right here. So because of the add sign in between there, we have to combine some like terms. So I'm going to recommend we take this guy and bring it to the other side there. Okay. So if you subtract 6x from the 13 that's already negative, you'd have negative 19x squared, and then it would equal 9. Well, we're going to, but you got to apply it in the right order. So work BEDMAS backwards.
Yeah.
And then square it.
Good.
You have to do it.
So we've taken care of our add and subtract. We now have to deal with the multiply, divide. Divide by minus 19. Divide by minus 19. Last step, we have to take whatever 9 over negative 19 is, and we have to square root it. We can do that, yep. You could say that x then is the square root of negative 9 over 19. You can just leave it in a fraction.
You can just do that.
Well, there's one more twist to this one here.
Oh, you can't because it's a negative. You
Good.
can't
Okay,
square it.
hypothetically, let's say you try putting it in your calculator, though.
Just not-
Can you square root a negative number?
The answer is
There is no answer. Yeah.
No.
Sure, no. So I know that seems like a weird concept. But like, let's say that I were to ask, I don't know. I guess maybe like shooting a basketball would be a good example. Shody's shooting a free throw and he shoots the basketball and he's aiming at the hoop right here. That's a hoop, I guess. And then I ask, when was the ball this high up in the air? The answer is,
No.
it wasn't. That is a very valid answer to a math question where I ask you, tell me when this happened, and you tell me it didn't, right? Now the answer is not 0 because it didn't happen at time 0. It just means that it's not physically possible. So this question right here has no answer. It's unsolvable. Well, let's try one more, then we'll take a break. I'm just going to rewrite it down lower again here. We've got 4 thirds of x minus 7 and 9 over 2 minus 2x. Start with BEDMAS. Do we have anything that's added or subtracted?
Yeah.
Okay. If you have things that are added and subtracted, it means probably they're like terms. So I'm going to highlight them in color here. This one and this one are the numbers. And this one are the x's. So, like the joke says, get your x's together and far away from you. So put your x's together on one side. Which side?
I want positive. You should put it on the other side. The X on that side.
So you want to bring this one over that way?
No, other way around.
Okay, so you want to go that way?
Yeah.
Okay, that works. So let's take 4x over 3, and if this is minus 2x, add 2x. And then you have 9 over 2, but then the 7 has to come over here, so add 7. So far, so good? Okay. We need a calculator. So we need to take 4 over 3 and add 2. And we'll make it into a fraction. So this side over here is 10 over 3. That's how many x's there are. Make sense? And on the other side, we've got 9 over 2. We're going to add 7. And that means there's 23 over 2.
Okay, so I missed that. How do you get 10?
Sure. The 4 over 3 plus the 2. I did that up here. 4 over 3. I added 2. It gave me 3.3 repeating. And then I used the fraction button on my calculator to make it 10 over 3.
Oh, it's not something I can remember.
We can, but honestly at this point here, since it's kind of our first day back in doing math, I think just the fraction button on our calculator works. But I can show you how to do that in your head, but it's not the end of the world.
Well, I have to figure it out.
Exactly. Everyone good up to that point? All right. At this point here then, do we have fraction equals fraction? Now I can cross multiply. So take the 3 and the 2 and cross multiply them. So the 3 will go up with the 23. That'll give 69. 2 and 10 will give 20. Thank you. And then last step, divide by 20. X will be 69 over 20. Okay, cool. Alright, that's it. That's all I got for the day. So how about, well, what I want to do some practice still though, okay? Because it's been a while since you've done this. How about this though? Go take a 5-minute break first. So can you guys come back at like, 7 minutes too? And then I'll show you what I want to work on in the meantime. So go take a 5-minute break then.
I'm so lost.
Sorry, I went too fast. Use the button calculator. You can do it by hand if you have to. It's been a while since we've done math too, so we'll work your way back into it. I'm trying to think. I think we did math first semester last year. Yeah. So it's been like a solid year and a half. First semester grade 11, the second semester grade 12. You know what, you guys are going to like this though, because we've done this stuff kind of before, at least to start with. So, it's not brand new. But we spent a lot of time on this. So.